Hello everybody, I'm Nick, and this video I'm going to show you how you can create a library like Mediator by Jimmy Bogard in C# from scratch. The reason why I'm making this video is because I think it's going to be very useful to people who want to make libraries and they want to understand the thought process of how you're going to tackle such an issue or such a challenge, if you may. And starting from scratch with no dependencies, no nothing, and me talking you through that, I think can be helpful to many people. I'm going to implement this in a sort of hackathon-y way where I'm not going to make every allocation matter and every speed optimization possible. I'm going to, maybe use reflection in some places, do some fancy things. But the logic behind every decision, I think, will make sense, and that's the point. Then you can take that and optimize even further if you want. Now, by no means should you be writing your own library for Mediator. Just go and use Mediator. It's there. It's awesome. But I do think that trying things out like this is a good exercise. If you don't understand how Mediator works or what it is, I do actually have a video on that, so you can click on the top right corner of your screen right now to watch that first and then come back here and see how you can implement it. If you like the type of content and you want to see more, make sure you subscribe and the notification bell to get alerted when I upload a new video. So what do I have here? First, I have a sample console app, which is what I'm going to use to actually use the Mediator library that I'm going to make. And I'm gonna sort of quickly show you what I want it to roughly look like. And then I have an empty .NET Core library here to implement the actual Mediator code. So first things first, Mediator works in a pretty simple way. And we're only gonna do the request response approach, not the notification one. We're gonna have some sort of request. We're gonna have some sort of handler. We're gonna have the Mediator. And we're gonna implement it like this, where request goes into Mediator, Mediator finds a handler, and handler does its magic, and then you get a response back. And that's the main idea of it. You don't exactly know where the handler is, and that's where the whole decoupling idea comes in. And then the handler responds back and you're happy. So we're gonna do that, and I'm actually gonna implement the usage and the Mediator code in tandem. So first we need the request, and for that I'm going to harness the response through the request with an iRequest interface. And here I'm going to have a tResponse type, and the reason why I have that is so I can enforce it on the handler level as well. Now, I know Mediator uses unit to represent void, and that's a great idea. I highly recommend you do that. I won't use unit. I won't introduce that because I'm going to have to explain that, and we're going to take a long time. So instead I'm going to use Boolean maybe or something like that to represent something that I don't necessarily want to return back. And now to have a request, I can go here and create my request, which will be print to console request, something like that. And then we have some sort of text and I want to print to console. So I'm going to say init here, very much how you would do in Mediator. And then you have an iRequest, and the reason why it doesn't resolve is because I haven't referred to the project. So I'm going to do that. And like I said, because I don't want this to return actually anything, I'm going to say bool, but I'm not going to do something with a boolean, and I'm going to return back. And that's the main request here. So all I want to do is remove that and say var request equals new print to console request, where text is hello from Mediator. And now I will have to implement either the handler or the Mediator itself. Let's go with the handler because I think it's easier to sort of define. So iHandler is what the user will have to implement to define how a specific request should be handled. And all I want to do here is have a T request and a T response, but I want to constrain where T request implements the iRequest that returns a T response. See what's happening here? We have a generic T request where it is constrained to return an iRequest of the T response that I have here. I'm going to show you why that's important. And the only method I want is a handle async method here that returns task of T response. So that's why we have it at the top level, and we're gonna say handle async, and then that handle async has the T request as a parameter, and I can also make this a contravariant. Let's not open that Pandora's box. I have a video on that very topic coming, so don't worry about that. So I'm gonna add the in keyword here. So that's all I need for the handler. And in my project, the way I'm going to implement that is I'm going to say, let me just copy the name, print to console. Here we go. I'm going to create print to console handler. And this will look like this, iHandler. And then the types I want is print to console request here. And then the response needs to be Boolean. And I'm going to implement the missing members. If I change the response to something like a string, this won't compile because the request specifically says I want this request to return a Boolean. So that's why we have that constraint there. And if this was anything else other than something that implements iRequest, it just won't work. So nice constraints here. And what I want my handler to do is the following. Take the request.text and print it to the console. So console.writeLine and take that. And then we can just return a task.from result with true. We're not going to do something with that value. Now, the whole idea of having that handler is that we don't have to explicitly call it. And that's where the mediator comes in. And that's where I'm going to go as well. I'm going to create a new interface and I'm going to create an iMediator here. And that mediator doesn't need to have any generics. All it needs to have is a single method. We're only going to do the request response approach, not the notification one. And I'm going to say task of T response as a generic here. And I'm going to say send a sync here. And then we're going to send the I request of T response. And this needs to go here and then request. And that's it. Nothing else, nothing fancy. Task T response, I request, T response, same constraints here. And I'm going to implement that to a mediator class. So I'm going to say mediator here. I'm going to implement the iMediator interface and I'm going to implement the missing members. Now, here's an interesting thing. We want all the handlers that Mediator will resolve to actually use dependency injection. So if this handler needed to inject some service, private read-only, something, I don't think I would inject the mediator, but just to give you an example, if I wanted to do something like this, where I'm injecting something, I want this injectable to be dynamically resolved. And there is a very easy way to do that, but it implies that you're gonna tie yourself to the Microsoft dependency injection framework, the built-in one. And not everybody's using that. The vast majority do, but not everybody. So in order to not exclude anybody, there's actually a way around that on the Mediator library. And that's why we're not gonna have any reference in that main Mediator library to any NuGet packages. We're gonna do it purely without any dependencies. I'm gonna say private read-only, and I'm gonna have a function that accepts a type and returns an object. And that will be my service resolver. And this is a very common practice in things like, some people do it with delegates. I like using the function. I really like functions. And then the reason why this is amazing is because I can actually, when I go back to my console, use the service provider and the get required service method that satisfies that contract as a way to resolve it. And then every other dependency injection framework has their own. We can use that. So to show you what I mean in the program.cs, I'm going to go ahead and add the Microsoft.dependency extensions.dependency injection, the full implementation. And again, this is not added in the main library, this is added in the consumer. And here I can say var service provider equals new service collection, and then add let's say transient for the print to request or print to console handler, and then build the service provider. So now we have the service provider. And if I was, this is done, and if I was to say iMediator mediator equals new mediator, all I need to provide for this to be satisfied is service provider dot get required service, and that's it. This works because now Mediator captured, but the way to accept a type and return an object is the get required service method of the service provider, and that's it. So we have that. However, this is not the only thing we need. Well, first, we don't actually have an implementation here. Let me just close that. So we need an implementation here, but we also need to keep track of all the things we can handle. We're talking about the request and the handler relationship. So a request will be mapped to a single handler, and that's how the handling will happen in the mediator. So for that, we're going to use a concurrent dictionary, and we're going to have from one type to another type. And that will be the handling all handler details. And now I will initialize that through the constructor, but I won't necessarily need a concurrent dictionary. I can change that to an I dictionary instead, and then just say new, and this will be automatically resolved. So the reason why I need that is because request comes in, I'm getting the type, I have to match to something to get the handler, and this information will need to be supplied up front to be able to work. And now all I need to do is say if actually we're gonna have to get the request type as a variable here, so we don't have to call get type multiple times, because that can cost us a bit. Okay, and then if handler details don't contain key for that specific type, meaning there is actually no handler for that, we cannot handle it, then throw new exception, no handler to handle request of type, and then we provide the type name. So this goes here. And then if we do, we're just gonna say handler details dot try get value, and the key will be the request type. So that's why we extracted it out var request handler. And then we have the request handler type. And now that I'm thinking about it, I don't need this to be a concurrent dictionary. It can be any type of dictionary. So I'm just gonna remove that because we're not really manipulating it once we instantiate it. So that's cool. And now since we have that, all we need to do is instantiate the handler using the handler resolver. So we're going to say service resolver, and I'm going to say request handler type, and as long as I have that in my DI container, it will create a new handler. And the last thing is to actually call or actually return the handler method. And this is where things get a bit tricky. Because of how we're using generics here, there isn't actually a way to cast the handler at its current form. Let me just explain this by actually showing this to you, failing to understand what I mean. So ultimately, we want to call the handle async method of the handler, but we can't because of how this fella works. Let me explain. If I say that I want this to be casted as an I handler of T request, sorry, not T response, let me just grab that, and I request a T response and T response. And then once I have that, I say handle async and I give it the request, and I also await it. Happy days. This compiles, but this will not actually work, and I'm going to show you why. Let me show you in action. Yes, we have that, and let me quickly create the dictionary that I talked about. So var handler details equals new dictionary of type and type. So all we're going to have is type of print to console request, and then type of print to console handler. That's it. And we're going to add that to the constructor. And let's see why this should, in theory, work, but won't. And I'm going to have an await here, change this to async task. Is that all I need to do? I think that's it. Mediator.send async request. And that's it. So let's debug this. Debugging. Here we go. So service provider created. We have the handler details. We go in here. We instantiate this, and then I'm going to step into this method. Request type, we found the thing. We instantiated the handler, and you can see that this created the right print to console handler. So we're good until here. But the moment I step over this line, boom, unable to cast object of type this to type that. This is, again, due to the use of generics and how this works, covariance and contravariance. It's a bit of a tricky situation. There is a way around it, and I'm pretty sure that's what Jimmy's doing, where you can create effectively a base class and then wrappers around that and misdirect the request handling. I'm not going to do that because I think that's a bit tedious to do on that context. Instead, I'm going to use reflection. You should not use reflection in this case. Not that it necessarily is very slow, but you could actually do it compile time if you wanted to, so you don't have to. But it's an interesting challenge nonetheless. So the way around this, now we have the handler, is to say handler.get type.get method, and then we're going to find the handle async method, I could use name of here, couldn't I? And then let's say invoke. So we're going to invoke that. The object is the handler and the parameters is the request. And this needs to be in a new object array because it's the parameter. Fine. And this needs to be cast into a task that returns t-response. And I'm going to await that and return it. Here we go. And let me just put that in perspective. So now this won't be null. This should work. And just to prove that, I'm going to not debug this at all. I'm just gonna execute that, and hopefully, assuming I did everything right, we should see the words, where is it? Hello from Mediator in the console. So I'm just gonna run it without debugging. Yep, here you can see hello from Mediator, and the reflection approach does work. Now, not the most elegant approach, but it does work, and there is a way around it. It's a bit trickier though. So we have the base idea nailed down, but you might say, okay, Nick, now somebody has to manually create this array or this dictionary every time and then register the handler and put it here, and there's so much room for error. How do you get around that? Well, that's mainly the most interesting part, I think, of this video, which is how do you create an elegant dependency injection extension method for your consumers? And that's what we're going to do now. I'm going to create a different project here because I don't want the Mediator library itself to know about this. I don't want to tie it to a specific package that if you're not using Microsoft extensions, a dependency injection, you won't use. So instead, I'm going to say add new project. I'm going to create a new console, class library, and I'm going to say dependency injection here. And that's it. And in here, I'm going to delete that class 1, which doesn't make any sense. And I'm going to say service collection extensions. And this is where the fun begins. We're going to change that to static, and we're going to say public iService collection. And this doesn't exist, so we do need to add the abstractions package here. We won't need the full package. Sweet. And we're going to say add Mediator. And ultimately, what the consumer should have to do is call that method and nothing else. The rest we can do ourselves. There is a bit of configuration, and I'm going to show you what that will look like, but mainly this is what they will need to do. So the other parameter that we're going to need here is params of an array of types, and we're going to call them markers. And these markers will allow us to scan assemblies to detect those handlers automatically and register them. And just to be a bit more fancy, we're also gonna force a way to register those handlers in a specific lifetime. So we're gonna say service lifetime here. And this service lifetime, if I go show you what it is, it's just your singleton, scope, and transient that exists in .NET. So that's it. And now all I need to do is first iterate over all the markers and say for each marker. And here's where my logic goes. First, we need to store the handler info somewhere. So I'm going to say new dictionary of type and type. And in case you haven't noticed, this is the same dictionary that I'm going to be injecting for the Mediator. And that is here. And then I'm going to get an assembly so I can scan. So marker.assembly. And then I'm going to scan for all the requests, all the things that implement iRequest. So var request equals assembly.exported types dot where, and this will be a bit of an interesting one. First, we want to find all the types that have generic interfaces. So generic interface types equals type dot get interfaces where is generic type, and we're gonna enumerate that to a list. And then we're gonna find all the types out of those types that implement the iRequest. So implement request type equals generic interface types where, and then get generic type definition equals to type of the iRequest. And obviously it doesn't know what iRequest means, so I have to inject, or actually I have to refer to the main Mediator library. So here we go, and this can then be enumerated to a list. Here we go, and I'm going to return where type is not an interface, and type is not an abstract class, and implements a request type. And why are you not happy? Oh, because this should not be where, this should be any, because we only care about whether we actually do that or not. And then we can enumerate that to a list. So this will give us all the requests. We also need all the handlers. So it's worth extracting that method, get classes implementing interface. And then we're also going to have the type here that we want. So first, this is, sorry, and the request goes here. This is being returned. This is requests, and this is a list of that type. And then type of, because we want to specify what we want. So it's the I request here. Here you go. And then type to match. Perfect. And we're going to say equals to that. And that should be happy days here. Now I should simply say handlers, and I need the comma because it has two parameters. So this should give me all the requests and all the handlers. And then for each request, I should find a matching handler and set it as type and type in that dictionary. So request.forEach, let me just expand that, handler info. We're gonna set that equals to, and we need to make sure that the handler matches to a request that has the same generic type on the request location, which is the first. That's a bit tricky to do. So we have to say handlers.single or default, right? I think that makes sense. Where get interface of a specific name, and we want it to be the I handler, and it has two generic types. So I don't know, backtick, whatever that's called, and 2 should give the right thing. And then we know this is not null. So we want to say get generic type, generic arguments should be the one. And we want the first one. This is a mouthful, but I think that's it. And this obviously needs to match that. So we're going to say that. I think that makes sense. And then underneath that, we have to say services.try add. And we're going to add the service descriptors because we want to specify also the lifetime. So we're going to say service service descriptors equals handlers.select, and we're going to select new service descriptors and service type, implementation type, lifetime. So it's XX lifetime. I think that makes sense. And now that should do what? Oh yeah, we never registered Mediator. So this is where we say services.add singleton, and Mediator needs to be a singleton I Mediator, and that is being implemented into a new Mediator that accepts the get required service and also the handler info. And now, assuming I didn't mess anything up, let me show you how simple that is. Instead of having to do all that with manual registration, I'm going to just comment that out in case somebody wants to grab the code and play around with it. All I'll need to do once I refer to that package that I created, the dependency injection one, is, let me uncomment this so it's legible, add Mediator. And then I'm going to provide type of program, so it scans the right thing. Oh, the first thing is the lifetime. So lifetime, I want it to be, let's say, scoped handlers. Should be fine. And that's it. And now all I need to do to grab a mediator should be var mediator equals service provider dot get required service I mediator. I hope this all paid off. And just so we have everything more concise, we have a print to console request handler, and let's add the second handler as well. Let's add something that, I don't know, give me a value request. I don't know, something like that. I request that returns a string. Doesn't need to have any parameters, and then give me a value handler, new class. Here we go, and we're gonna say I handler, and we're gonna have give me a value request here. And what did we say the return type is? A string. Sweet. And we're gonna implement that. perfect, return task.from result, hello from Nix Mediator, and this will return the string back. And in order to showcase that, we're gonna say var result equals new mediator.handle.send async new what they call it, give me a value handler, a request, sorry. And that's it. I know that's a bit confusing, so I'm gonna debug that so you see what's happening in that method. I'm gonna make that smaller, and I'm gonna say let's go. So we say add mediator, we hit that empty array, we scan the markers, we get the assembly, we find all the requests. We found two, the give me a value request and the print to console request, and then we find two handlers hopefully as well. Yes, we did, and we are going to iterate over them to map them and add them into the request handler. So assuming I did this right, it mapped to the right one. Let me just expand that. So give me a value request, give me a value handler, give me a print to console request, print to console handler. So this works, sweet. Now we get service descriptors for those things. They're both scoped and they have the correct implementation. Nice. We don't have any other markers. We add the mediator here, and now service registration is done. We grab the mediator from that application. You can see we have two handlers that this mediator can handle, and the first one goes over, it will find the right handler and invoke it, and as you can see in the console, this says hello from mediator. It didn't invoke any other wrong handler, and then we call that as well, and we should have awaited it. So I'm gonna quickly put an await here and rerun this real quick, and I don't need you here, bye, and step over that, and the value is hello from Nix Mediator. So we proved that we can have two requests, two handlers, a single mediator handling all that, all in under 40 minutes, which is pretty nice. And then we can just keep iterating on it and build something if we want with pipelines and a bunch of other stuff. But this is the basic idea. It's the idea that, yes, you're gonna have to use reflection for initial registration for the mediator, but after that you're going to use a built-in dictionary. Now, yes, we do actually use reflection in the bad way here, and I do understand this is not how you want to do this. This is where you would spend more time to actually properly implement this, but it works. It's a hackathon way, like I said in the beginning, and it serves the purpose. It illustrates the point. This is how a mediator works. I really hope you found that fun and useful, because I do think there's some very nice, interesting points here, especially around this registration, taking that pain away from your developers who will use this library, or any library for that matter, and do a lot of smart stuff behind the scenes for them, and just provide a nice add automapper, add mediator, add something for the dependency injection without tying them to a specific framework in the core library. I think it's a very nice way to go about things and libraries in general. That's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you can find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well, and I'll see you in the next video. Keep coding.